we've had automation tools forever and ever and ever, and nobody ever turned them on because flipping that switch was a big concern. Because how can we trust it enough to do that?
Eric Hanselman, I am so psyched to have you on the podcast. Welcome, Eric.
It's great to be here, Nick. Thanks for having me.
Yeah, I gotta tell you, you look better as you age. You really do.
Somewhere there's actually a portrait of me that's like aging somewhere in a closet. But yeah.
Actually, in your hair, didn't your hair used to be dark, like years ago, or is it always kind of lighter?
Oh no, it was definitely much darker back in the day. So, yep. No, those strands of gray have made their way in over time. Yep.
It looks more blonde than it looks gray.
Oh, well, shoot. Now my driver's license, it now says gray. So I think this is mostly just the light hitting it just the right way. So,
all right. Well,
I have to keep this look going. So
it looks good anyway. Yeah. So anyway, so like I said, thanks so much for taking the time to be on the podcast. Really looking forward to this chat. And you've been always like so generous, like with your time and also in support of the community, of the ONU community. So first, I wanted to say thank you for all of the time that you've spent with the community and all of the thought leadership, the great thought leadership that you've been able to share with them. Because I think you've been there from like the very, very beginning.
Oh yeah. And it's a two-way street. This is I get probably more from the ONU community than I contribute. It's such a great collaboration across a whole set of folks who are just trying to get security. Well, whatever back in the days it was networking, all of the different insights and stuff. I was just thinking about the most recent, talking about some of the security things around this, but it's such a breadth of topics. It's so many different things. And such a it's the quintessential 1 + 1 = 3 kind of story. It's when the community comes together to address whatever the issues are it's looking towards. Just all sorts of goodness comes out of it.
Yeah, well, thanks so much for that. Because I do feel that. I think it's that it's interesting too because so many things happen that I'm never aware of because you can't be, right? All of the interactions, all the discussions, like all the business deals that occur, all of a sudden they start to set the industry on some different direction, and personal gains, corporate gains, occur from it. So it's actually really been rewarding from that point of view. It's like, and I might not hear of something until like, almost like a year later, it was BP, British Petroleum. They were doing kind of an SD-WAN evaluation, and we had published, kind of an SD-WAN, kind of like a test and a checklist, and they used that as part of their RFP, and it was like, I don't know, 2 years old. Even though it was like 2 years old, they still used that. And so anyway, little things like that, you just had no idea how you're contributing, but you do, and
it's being able to be the catalyst for so many of those conversations because, especially now when we're living in a world in which, if you look at a lot of the conferences and a lot of the gatherings that are going on, they tend to be pretty vendor specific, and it's just become rarer and rarer to get an opportunity to just hang out with like-minded people and talk about subjects of interest and actually have meaningful discussions around it. And that's one of the great things about the community.
Yeah. Awesome. Well, I want to start off with making sure everybody knows you and your background. Like I know, like, you're so popular and, you would think that everybody kind of knows who you are, but, for those one or two people out there that don't, So want you to talk a little bit about your career journey and kind of what brought you to S&P, Global, and now as their kind of chief analyst.
I'll give you the full origin study. It's not
Yeah.
like as dark as some superheroes, but no, yeah, I come out of a non-traditional analyst background.
Hmm.
I'm a chemist by schooling,
Huh.
and I wound up and so much of chem these days is instrumentation, or back in those days it was
Hmm.
instrumentation. It's how I got into computing. Started doing a lot of high performance analysis. Was doing some digital signal processing, which DSPs were kind of like the GPUs of their day,
Hmm.
uh, and had been living in sort of the analytics side of the world for a long time. Wound up making the jump to vendors who were actually trying to connect all this stuff together. Because once I had all this data, the next stage was actually the networking piece of it.
Hmm.
And so went through a whole set of early stage startups. I mean, Wellfleet back in the day,
Yeah.
and a bunch of other startups doing both sort of network and security. And I'd actually been doing virtualization management at Leostream, and decided to step aside as they were looking to head into new directions. And I had been working with uh, the 451 research team when I
Hmm.
was at Internet Security Systems and at IBM. I knew the team, and they were actually restarting the networking practice, and we're looking for somebody to pick it up. And I thought, well, that might not be a bad thing to dig into. It's a really good group of folks, some really
Hmm.
interesting work. And now here I am, the other side of a decade, having done all this. So
It's.
that's how I got
Hmm.
here.
I think that's actually really great, and that's probably why you're so good. Um, you come, to this with a technical degree and a technical background, and so that affords you to be able to explain things, you know, um, to people, So that's I didn't know that, So that's like, that's super, and we were both starting around the same time, during the beginnings of the internet. Like I think I started really kind of doing analysis stuff or analyst stuff around 91. Yeah, 1991, 92. Yeah, around that time frame. I got like 33 years ago. So it's like, you know, so, and that's, it was around, it clearly was the kind of mid to early 90s that Wellfleet, Cisco, Proteon, like, all those companies, were competing to build the internet. It was actually an amazingly fascinating time, to be young and to be starting a career, because, like, it's like I'm sure neither of us really realized how big this internet thing was going to turn out to be. It's
And
like,
who could have envisioned this, right? I stumbled
mm,
across one of my old business cards back from when I was at NEC,
mm.
that had you remember the old Bang addresses? You
Oh
know,
my, yeah,
it was, back before you had real name resolution, back
yeah,
before you had any of the real sort of more sophisticated things like, how would you actually get a message from here to there? Well,
yeah,
you gotta know who you're going to relay it through in order to
yeah.
get it there. It's like this routing business. Well, yeah, we'll figure that out.
Yeah, that's okay. That's going back a little bit. All
Yeah.
right, so let's
Yeah, I
start
was fighting
to.
off saber-toothed tigers, when I was running fake cable. Yeah,
Cute. All right, let's dive into like some of your research areas. So you both focus on service provider as well as the large enterprise, right? So um, I know you have some pretty strong opinions on kind of cloud native telco networks, and how that community has been trying to monetize the telcos have been in a tough spot. It's like ever since the cloud era came, they've been, I think, kind of struggling. And it's a shame because if you have a different view, please feel free to express. But it seems like when COVID happened, everybody had to do VPNs and remote access, and that was all the telcos. But but all the cloud providers got the credit. It's like,
Well, it's kind of the same story over and over again, right? Because if you look at over the top applications, there have been a lot of things where you kind of would have figured that the telcos had a right to own a lot of that capability, and yet, there were challenges that they faced in order to really deliver on those kind of businesses, and cloud native is the same kind of thing, and some of that is just intrinsic to the way, telcos find themselves in a really tough spot
mm,
because they've had to get to levels of automation that your average enterprise hasn't typically done. Because in order to scale the business, you've had to go automate. The challenge though is that they had to do it early, and they typically did it in ways that were specifically service oriented,
yeah,
and they worked well for the specifics that they were trying to achieve. But now you've got these relatively complex automation environments that are running these individual services, and it's
mm,
now high risk to change any of that. So,
mm,
you wind up in that situation in a bit of a bind. You'd like to be able to shift towards kind of the speed that you can get with cloud native, to be able to move towards more general purpose kind of capabilities. But yet you wind up risking what is the big revenue generator for the business if there are problems in transition with any of the services.
yeah,
And so, they've had that challenge of having to, it's the innovator's dilemma, right?
mm,
Uh, do you disrupt what you're doing in, in order to be able to get there? Um, there are more and more of them that are getting out and doing more and different things. There are innovators that have been able to do interesting things in terms of how they're actually building networks.
mm,
I think of people like Rakuten and Swisscom. But if you were to turn that question to any of the larger, more established players out there, they'd make the point that a lot of this was greenfield.
yeah,
They didn't
mm,
have a lot of legacy environment that they had to move forward with. They didn't have a lot of those challenges of risking an existing business.
mm.
Um, and there are you know good and bad sides to both of those questions. It's that question of in technology, shouldn't we really be thinking that we have to disrupt ourselves on a pretty regular basis and plan for it? But I guess, can you plan for disruption? It's a
It's
tough
kind of,
call.
yeah, it's hard, because not to like belabor the point, but the telco space is a really difficult one because they're trying to offer like the same service for like so many people, for so many customers, and as the world has gotten more kind of customized, and the architectures have varied, and especially as we've gone like kind of multi-cloud in particular, it's kind of hard to find a one size fit all. Like I think the last time we had that was with MPLS, and and the MPLS market, it seems to have imploded, right? And so it's the SD-WAN marketplace did a
But it
good
took
job.
so long to happen.
What my God, yeah, like a
I've been
decade.
predicting, me and a whole boatload of people have been predicting, MPLS transitions for how many years?
A decade at least,
Oh yeah,
yeah, at least a decade. Yeah.
we did a study. Oh geez, a bunch of years ago. Got to be 5 6 years ago, and talking about MPLS transition ideas, strategies, strains. What were organizations thinking about,
Mm,
and even at that point where SD WAN was starting to get pretty well established, and the thing that I always thought was interesting about SD WAN was, now we were actually instrumenting networks in ways that you were actually giving us real feedback
yeah.
on
Mm,
exactly what the quality of all the various networking capabilities we had was really like. And in fact, people were starting to realize, wow, there were still some challenges in MPLS reliability in the same way that we'd seen in other environments. Uh, but even though a lot of that information was out there, a lot of those ideas were out there, the faith in the reliability of MPLS was really strong,
mm,
and that really seems to have carried it along. I mean,
yeah.
it's, I guess, in a lot of ways, the technology is less risky than the technology you don't know.
Yeah, well, it's like I think it's the bottom line is that is it really worth it either to try to save a few dollars off of your budget, but consume a lot of risk? And so I think it's I think that was really it. And then and then these folks were always really good. Like whenever like you'd go back to renegotiate, like usually after like a 3 year or a 5 year deal, it was always a lot, like so much more cheaper, and you got this really great ROI. So I think it kept it alive for a really long time, and there was just a strong ecosystem there. But but
Well,
the world
yeah,
has changed,
I think it's one of those things that we always sort of face in networking, which is, networking folks are risk averse.
Yeah.
And I think it was Andy Jakewith who'd made this comment way back when. It
Mm-hmm.
was contrasting the difference between changes in network and changes in compute. And he
Mm-hmm.
was making the point that changes in compute, you're doing one small thing to a whole bunch of independent systems.
Mm.
And so risk can be relatively low.
Right.
Whereas networking's exactly the opposite. You're
Yeah.
making one small change with a whole bunch of interconnected systems. And
Yeah.
so the challenge of really messing up a whole bunch of stuff is just that much higher.
Yeah.
And
Yeah.
that risk aversion really is one of those guiding principles in networking. And I think with pretty good reason.
Yeah, no, for sure. Yeah, well, we've always said it's like everything runs over the network, and so it's like
Yeah.
if you're making changes and you mess up the system, yeah, like oh my god, you're going to be so unhappy, or make so many people unhappy.
Mm.
Well, okay, great. Let's actually, I do want to stay on this topic for a little bit. So, so we know we've had kind of the SD-WAN stuff. There's SASE, there's SSO. It seems like, and which is really about kind of converting, the conversions of networking and security in the wide area. So, I don't know what's your take. Have are there companies that you kind of look at as kind of leaders in that space, or is it still a kind of security bolt on to like SD-WAN?
Well, this gets back to the real question of, as an organization,
Mm,
how can you really digest these kind of technologies?
mm,
Because the whole point with SASE and more broadly with SSG is that it's the same thing we've done in networking forever, right? We crammed so much functionality into the network.
mm,
Uh, all of the kinds of things, business logic that gets sort of stuffed into network implementations. SASE has the promise of giving us the ability to actually have some integration across what had been that hodgepodge of all of the different elements in the network that were actually taking care of that stuff.
mm.
And with a healthy sprinkling of identity, which is the thing that we always had to sort of intuit from the networking side.
Yeah,
Because so much of what we're doing on the security side of networks is really trying to figure out what's happening, with all of the traffic generation that's happening up above us, and sort out all the context that we don't have. Uh, and SASE starts to tackle a bunch of those problems.
mm,
And I think for most organizations, the question is, how do you consume that and integrate it?
yeah,
And it's really sort of moved forward with the same sort of progress I think we saw in the SD-WAN model. We wound up with the sort of the first phase was DIY. Everybody was out there buying their
yeah,
own boxes, rolling out their own stuff, and those folks who are implementing it were really the ones who had the strongest motivations. That they were the folks that needed that kind of control, needed the security when you got to SASE, and wanted to be able to really take advantage of a lot of the promise that they could actually uh, get to and hopefully deliver on. And if you're trying to manage access, if you're trying to get to a zero trust footing,
mm,
and SASE is a great way to be able to blend all these together. But for a lot of organizations, especially those with a more mature footprint, it requires a certain amount of integration, and you got to bring together a lot of the different elements that you have,
Yeah.
and it means transitioning away from the way you were doing it before, and we get right back into that networking concern about not wanting to make transitions and managing that risk. And right back to the point that you were making about risk, what just like MPLS, is going to be that much more comfortable.
Yeah.
The difficulty though is that with security, the landscape advances rapidly enough, the challenges advance rapidly enough, and I think the thing that the pandemic did, along with a couple well publicized issues with a lot of VPNs that are out there, started to get people realizing that actually maybe these are environments that came with a bit more baggage.
Mm.
Because
Yeah.
because VPNs and a lot of the remote access technology we had was the exception way back when,
Yeah.
and suddenly the pandemic hit, and remote access was the main access means, and everybody realized, oh wow, using this at high scale
Mm.
and at high volume, and to try and get real work done with it, it was really hard.
Yeah.
So yeah.
Yeah, but thank God we had it, though. It's like
Oh yeah.
it's
Yeah.
better than better than nothing. That's for sure. That would have actually really just collapsed the economy. If we had no way of kind of connecting back.
Well, and if you think about what
Yeah,
networking teams went through,
yeah,
throughout all that, I mean, I look at all the things that were going on around ONUG,
mm,
as people were just trying to make that transition happen, trying to manage the risks associated with it, and then cleaning up everything that happened afterwards. Like,
yeah, yeah, and then also trying to dismantle. Because they realized at first, like when it hit, the pandemic hit, they said, okay, well, how are we going to get 50,000 people connected? Okay, we got VPNs. All right, let's just scale that up. And then they scaled that up, and then they're like, oh no, we have 50,000 people on VPN. It's like, all right,
it's like
we got to do
shift into
something else.
reverse. How do we? Absolutely.
Oh well. So in one of your podcasts, kind of the Next in Tech podcast, I was intrigued. You
I
started talking
appreciate
about.
any shameless plug for the podcast, so by all means.
Oh yeah, yeah. It's like well, first, like I think in the last one, or like in one of the previous episodes, you start talking about like I think smart spaces. Yeah, smart spaces, which
Oh
is
yeah.
kind of the OT and IT kind of convergence. So can you like talk to that a little bit? And also like we'll put in a link to like your podcast when we release this to the general community. So
Oh, much appreciated. Well, and I will also do a shout out to Zoe Roth, who is the lead analyst in our smart spaces area. But yeah, it's interesting what's been happening. Because we were talking for so long about smart cities, and
yeah,
that was sort of the realm of jetpacks and hover cars, and all those good things of the future. But realistically, uh, we're getting to a critical mass in terms of the amount of sensing technology we've got,
yeah,
the ability to take a look at what's actually going on, uh, and more importantly, some of the protections necessary to manage a lot of those concerns about privacy and data sharing that's potentially going on.
yeah. It's interesting too because like the way that we viewed smart cities is that we'd be able to control traffic more. You'd have access to, identifying where there may be an empty parking spot, because of like sensors, in it. You control energy, based upon demand. So there was like all of these kind of like almost like centralized. I don't want to say Big Brother, but like kind of more kind of centralized, systems that people were envisioning. And now, okay, well, we have self-driving cars. If you drive a Tesla, you do, or a Waymo, right? That will find parking spots for you. Like I've had a Tesla for like 12 years or so. So it's like, yeah, I use the summon feature, It's not quite there yet around kind of parking, or finding a parking spot for you, parking it. But like the next version of it, like with kind of the AI, um, 5, a hardware kit, and when we have unsupervised full service driving, like that's, to me, that's a smart city. It's like all of a sudden, like, okay, I drive to the airport, and I send my car back home, and I send it back to pick me up, or I summon it to pick me up. It's like, so it navigates, not only the roads, but also it navigates traffic. It can take different routes, so it's like it's very distributed, not centralized, in really how a smart city, I guess, really is becoming reality. So it's just much more distributed than it is centralized. I'm not sure if you agree with that. You're much closer to this space than I am. I'm just, kind of an observer, of it. But that was my kind of, 10,000 foot observation.
Well, you're right on the mark, which is it. The historical view of that was, one major view of the entire planet, city, what have you.
Mm,
But realistically, it's being able to bring together all of the various spaces that exist out there, to
mm,
be able to share enough information about them, to be able to make people's lives better.
mm.
And whether or not that
Yeah,
happens to be managing energy use. So if you happen to be in a building, do you know who's in the building, managing the heating and cooling systems, uh, but even much more fundamental things of being able to now look at how that interacts uh, in a lot of those extended interactions that happen in the city day in and day out.
mm,
How do you actually coordinate how many people are going to be in the office on a particular day? We in our S&P's offices, uh, figuring out who's going to be in any particular day. If there's an event that's happening, it can go from being really easy to get a desk in the office to being really hard. Uh,
really hard. Yeah,
and how do you coordinate that uh, along with some predictable mechanisms to be able to then manage the people who are in the building?
yeah.
How do you actually work with the city to figure out how much parking is going to be needed? Do
Mm,
you have a major storm that's coming along? Are people going to be parking in garages more because there's a storm? How do you start to integrate some of that information
yeah.
and then work on it's so much of this are second order impacts.
Mm,
It's the basic thing of finding the parking space, okay, but can you look at the second order pieces of could you free up more parking spaces? Could you have anticipated where this was going to go? Can you change parking rates to change where people are going? Can
yeah,
you change traffic lights to slow or manage how people are getting to certain areas? That kind of stuff's already happening today.
yeah.
And I think back when I was at IBM, I got a just a very slight view into the inner workings of what was happening in New York back in the day,
Mm,
and the fact that you now had the ability to have at least that visibility. Um, a lot that's going on to simply make that a whole lot more fluid, and to also understand what really that change is. Um, the other big piece of this is the evolution of sensor technology.
mm,
Uh, if you take a look at what we've been doing, way back when, it was magnetic loops in the streets sensing cars going by.
yeah.
Well, now, and it's not just for traffic. Now the camera has become the universal sensor for everything. And
Mm.
we've been able to put enough computational power into cameras to now be able to make them smart enough to be able to do just as well as a lot of the systems, the big physical systems that we've had in the past.
So, do you think the sensors then, because the sensor, there was kind of a movement to make them really lightweight. Um, don't do too many things. But do you think there's more kind of like a focus on making them heavier? Let them do more processing, kind of locally. and not rely upon kind of centralized systems to kind of process a lot of the data.
Very definitely. And one of the big
Um,
advantages is that there are privacy benefits. Now
hmm,
you can start to do a lot of that masking of data and just share metas. Now it's like, hey,
yeah,
there's here's a car that's this big that is waiting at this traffic light.
yeah,
As opposed, and if we had to go pipe the video feed back someplace, if we had to do analytics, if you're doing the direct analytics on the video images, then
hmm,
there's the risk that you can do license plate identification, driver identification, all
right,
sorts of
yeah,
things that start to raise a bunch of data concerns.
yeah,
But if you can distribute that out to the actual sensor, now more of the work gets done out there. Now that you get sensor costs, it's no longer crazy expensive to get a fair amount of computational horsepower actually out in an individual camera.
yeah. Well, I think what's going through my head right now as we've been talking about this is agentic AI. Because a very similar kind of model, right? So especially in networking or in infrastructure, maybe different if we're thinking about kind of the application space, or kind of the consumer side of things. But like in networking or in infrastructure, a lot of discussion going on right now just about what is a new model for lifecycle management around infrastructure that reduces the burden of humans, on that system, since there's such a shortage of security engineers and networking engineers anyway. So there's a big gap there. Could a new model where a lot of the against really in essence like kind of lifecycle management of that infrastructure gets automated, and part of that is having agents that are lightweight, they're distributed throughout the infrastructure. A knock, may make some particular request, or a level whatever engineer one, two, or three has their co-pilot with them, or launches a bunch of agents requests, and then that gets distributed out, and then there's a directory around okay, which agents can satisfy the task that's required, and then starts to do the task and starts to coordinate and communicate with agents that are distributed. Maybe I'm sorry to kind of go into like all of that detail, but it's like, but in essence, really, let's start talking a little bit about AI, and especially in our industry. So this is kind of like AI for infrastructure, and not so much of infrastructure for AI yet. All right, so.
Well, you made what's probably one of the most important points around this, which is
Mm,
ensuring that agents are tackling, small, reasonably atomic tasks.
yeah. Mm,
Because one of the biggest problems with AI is that we sort of wind up getting under that AI spell and thinking, wow, this is great, and it can do all these things. We're going to make one huge agent to rule them all,
yeah.
and and that's where we really start getting into potential levels of risk.
Yeah.
Um, this is the same thing we've always had in network automation, right? I mean,
Mm,
what's the challenge? We've had automation tools forever and ever and ever, and
mm.
nobody ever turned them on because flipping that switch was a big concern.
It was scary.
Because
Yeah.
how can we trust it enough
Mm,
to do that? And the thing that agentic approaches now start to give us the ability to do is two things which I think are important. One, to do that assistive work, which is give me the context, tell me all of the differing things, the problems we've always had. What are the tough tasks in network management? It's resolving outages, and it's figuring out, okay, what's broken and how do I fix it?
yeah.
And other than, hey, undo the last thing you did, but uh, you know,
Which is
getting to a
still
point at which,
very valid.
well, yeah,
Yeah.
this
Yeah.
is
It's
one
like,
of those things in flying. It's like rule one: whatever you did last, undo that,
yeah.
and then you put it now. Try and figure out what's wrong. Uh, but it's being able to get to a point at which you can get, your networking team the information they need, because so often the biggest challenge is just collecting all the, sufficient information to know enough of what's going on.
Mm.
Is this a reachability problem? Is this a DNS problem? Is this, or is there something that's a peering issue out there that's something's going on? Physical failures are
Yeah.
still, they still happen, but so often you wind up with, config issues, versioning issues. I mean, what's been the way in which we've run networks historically, right? We
Mm.
figure out which router versions are all going to play well to each other, and then stick with that version. And,
Yeah.
heaven forbid that anybody, does an upgrade, because who knows what it could break.
Huh.
To a
Don't
world in
breathe
which,
on it.
exactly, don't
Don't
touch
breathe.
it.
Yeah. All right.
And to get to a world in which we can actually think in a little more detail about what's actually happening.
Mm.
And the point that they're making about keeping, things reasonably atomic is the path to success there. It's the thing. It's, do the small stuff. And the nice thing about it, we see it in coding assistance already. If we think about
Yeah.
probably where that's moving the most rapidly, and
Mm.
the place where that can be the most helpful is that sort of ride along. It's the over the shoulder. It's sort of like, it looks like you're about to do this.
Mm.
Here's some insights. Oh, hey, those lines of code you just put together, that actually has got, there's a fence post error there.
Mm.
Those kinds of things where it can be assistive. And
Yeah.
and networking, because of its level of complexity, is just the same.
Yeah.
We should be getting to a point at which, we can do configuration changes with, that level of assistance. It can give us the context, and it's like, and all of those sort of next stages of, wait, what was that host name? What was that? Which VLAN was that?
Mm.
All those kinds of things that the small stuff that
Yeah.
relatively low risk, relatively easy to implement, and more importantly, something can help us build trust and understand.
Yeah. It's like the movie What About Bob? It's like baby steps. It's just kind of, and that is really, I think, the strategy for gaining trust, right? Because I think that is the biggest hurdle, is that, okay, how much do you trust this? And so if you do a large, amount of activities that could blow up in a really bad way, then that's a problem, But if you can autonomize them, as you said, into very specific tasks and have agents that are really good at those very specific tasks, then that trust will build up, and then you can build, upon that trust by adding more and more kind of agents into that environment. And so I think, so it's interesting. I had Helen, I think it's Helen Gu. She's one
Oh,
of the founders. Yeah, have you met Helen?
indeed.
Yeah. So so from Insight Finder. So she has. So they basically have a kind of an agentic kind of system in place, and so she was, you know, in some of the largest financials, as well. So this isn't kind of like this rocket science, and like, it's going to be here one of these days. Like, actually, companies are actually deploying this. Like, was it J.P. Morgan Chase? Has like what 20,000 agents, deployed already for multiple different uses, not just the use case that we're talking about already, that we've been talking about in the networking. But with what Helen was sharing, one story where there would be this application that would time out over and over again. And it was then kind of making these requests, into their storage, and that their storage lake would then crash. And they could not figure out what was happening, what was causing this. And it turns out, once they kind of like put the Insight Finder system in place, they realized it was an old switch that was timing out quicker than the application's response timeout. And that was creating this kind of weird loop um, of kind of requests coming in, and and not responsive, and you know all of a sudden then flooding of the amount of data that was coming in from storage. And it's like you would never be able to identify that, just to trying to get to root cause in really complex systems is hard. You have like one incident, and that can send, depending upon the size of the environment, 10,000, 20,000 alerts, and then you got like a team, of engineers that are going through massive data sets to try to figure that out, and so I think that, this area is really ripe for that kind of automation to come in. And it was Parentap from eBay that coined this analogy. And he said that the way that we're doing operations today is like the haystack model, where we have all this telemetry, whether it's S-Flow or just open telemetry links that are sending all these alerts, alarms, and system data into these data lakes, and then something happens, and then someone says, find out what happened, and it's like all of a sudden, like, you have this big haystack, and it's like somebody just throwing a needle in there and saying, find the needle. So I think it's that kind of system that just won't scale anymore. When you think about it, like Intuit, it was Bruce Pinsky that mentioned at one of the ONUGs that they basically ingest about 20 petabytes of data into their Splunk system a year, and that was back in 2018. I can only imagine what it is now.
Yeah.
So it's not just the millions of dollars, but it's just like the volume of data, and that's just like I said, I think that's just unsustainable, because if we and it would be really great to get your perspective on this, Eric. But I think John Chambers came to the last AI networking summit in Dallas, and John had a lot of good points. One point, in particular, is the rate of speed or the rate of change that AI is now driving. And so he's like saying, well, the transition that started Cisco, and you and I were both there, was the internet. And then in the kind of mid noughts, or kind of early noughts, like 2008, 2007, we started seeing cloud come online. And John's basically his observation is that this is going to happen faster than both of those, and it's coming bottom up. And it's not because, like cloud, you had to do a lot of convincing to executive management. You had to spend a lot of money on those Sunday talking head, news programs, to try to get to executives to convince them, hey, this is going to be cheaper, it's going to be better, it's going to be easier to do cloud. Here, we don't have that really. It's really more bottom up, and people are just seeing the value of it. So anyway, your view, like on. I kind of threw a lot in there, Eric. Sorry,
Well,
but I would like to get your view on the whole movement that we're seeing right now in the general economy around AI.
and so, not surprising. I look at a lot of our end user data, voice the enterprise data, and um, it frankly, yeah, there's a lot of support, which is a little concerning.
Mm-hmm.
Back in the day when people were moving to cloud, there was a reasonable amount of executive support, and there was that sort of like, yeah, we need to get a cloud.
Yep.
And now we see, this is all the way up to board level support, and when you get that kind of level of initiative, um, it's people are pushing forward, and maybe biting off a little bit more than they ought to really be chewing. And so
Mm-hmm.
that's one of those points that I actually sort of say, well, this is why I think it's doubly important to be aware of how you head towards this. What you figure out you're going to do for use cases.
Yeah.
Now, granted, is there a lot of work to do? Oh, heck yeah. Uh, if you look at again, we look at our security side data. We've got 5 years of looking at, asking the question, how many of the security alerts that you see that you think you should be able to get to do you not?
Mm.
Um, that hit a peak last year of over half. I think it was
Half.
54. Now,
Yeah.
now the good news is this year, the most recent study that started to come down. Maybe that's driven by greater adoption of AI tools. We don't know for sure. Um, but there's a lot of work to do. And as you were pointing out, that whole sort of haystack mentality of we're just going to dump everything into this great big humongous lake and then figure it out later. Um, yeah, AI is a mechanism that gives us some ways to work through that,
Yeah.
and there's a lot that we can do to help build context. Now, the other part of that, which is I think the thing that you were alluding to in this, which is you got to make sure the quality of the data that you've got
Mm.
is actually going to help you do that, and that's the biggest issue, which is we got just vast quantities of unstructured data. All these logs,
Mm.
all of this data that we just sort of chucked in there. If it didn't arrive with all the necessary context to make the stuff work, um, now we're at a point at which we've got to do a little more work to clean that up. But AI can help with that too.
Yeah, yeah. The schemas are all different. You're right. The data structures and formats are really all different. So totally with you. On that. But and I think the one good thing that we have with these AI tools is that the way that we used to try to deal with that is that either we would try to provide a canonical format and we would map all that data into this canonical format, right? Which is problematic and difficult because like everybody's schema changes, and so you're chasing after keeping up with the schemas, or that you would have these modules very specific for particular vendors, right? And then those modules then would kind of interact with that data or ingest that data, and then it would then canonicalize it. So there's I think that's the only thing we had. So like finally now, if we have tools, AI tools that can ingest this data and then do its own canonicalizing, of it, independent upon where it's coming from, and then normalize the meaning, of it, as well. That's huge, right there. That's huge. Then you can actually act on the data. Or you can see correlation, between events and between data. And then, hopefully that will then, it should anyway, it should take that 50%, of, I haven't seen the number that high. Usually I've seen around 30% of data or events that go, unaddressed just because just the load is just too high. But if it's like 50-30, can you start to narrow that gap down? And that would be huge. That then, okay, you're kind of reducing vulnerabilities and you're reducing hopefully a blast area, surface area, blast area, for your company. That's great. Actually, good use case, and around the security, around the SOC in particular.
Yeah, because it's something where we got history here. I've got a four-letter word for you, SNMP,
Yes.
and if you contrast that with where we are, because you mentioned open telemetry,
Yeah.
and especially what's happened with all the movement to greater levels of observability, it seems like we've learned lessons of the past. We're not, we're getting beyond a lot of the vendor specific stuff that's out there that was a big challenge, and a lot of the legacy telemetry that we generated.
Yeah.
Um, there's still work that we've got to do around it, as you're pointing out, but we're at least in a point at which we've got the ability to collect sufficient amounts of data. We just need to make sure that we manage it well.
Yeah. Yeah. For sure. So I think then, Eric, how, so it's interesting. So like, let's kind of compare notes. So on the consumer side, on the enterprise side, so AI infrastructure spend is dominated by five companies, right? In the hyperscale, on the hyperscale side, um, unless like you're in like if you're doing kind of full service vehicles, kind of driverless vehicles. You're doing drug discovery in the pharmaceutical space. You're doing humanoid robots. You're doing fraud detection within the financial services, sector. Um, or you're doing kind of research around disease treatments and disease prevention, as well. So those seem to be kind of like the major, industry sectors and projects that are being funded outside of like the hyperscalers. But I think what we're seeing is that mostly like within the owner community, there is like clearly some focus around the lifecycle management that we've been talking about in both infrastructure, so networks and security. But in terms of like building large GPU clusters, not so much, right? And so, but they are in a phase right now of deep understanding. They can't get enough, information about kind of how to build this stuff. What's the architecture? What's the blueprint? What's the recipe to build it? Because they know it's coming. And I know we've seen some data where it'd be interesting if you have any of this data as well. But it looks like the large enterprise will outspend hyperscalers like within the next 5 years, if you can believe the data. So like 2029 is the crossover period, and as you go further out, then large enterprise is the biggest consumer of AI infrastructure. I don't know. Does that kind of jive with what you're also saying?
Well, the question in sort of the overall spend and directionality in terms of where that's headed right now is that we've been living in a training world for so long.
Yeah,
It's easy to see a lot of sort of the training focused consumption that's been generated,
yeah,
and extrapolate from that.
mm,
The if we take a look at where the work's being or will be done, it's all going to be around actual inferencing. It's all going to be the work that all of these
yeah,
millions of little baby agents that we've been talking about are going to start actually accomplishing. And if we think about sort of overall spend, that's that piece at which, if you think about enterprise work, hey, the vast majority of enterprise work is all going to be done around inferencing activities,
yeah,
and that's some of where that shift goes. Now, the trade-off in some of that is that we're going to start to see a lot of the AI functionality integrated into capabilities that already exist today. As I was mentioning earlier, we were talking about sensors,
mm,
and sprinkling a little AI capability into a sensor starts to make it a whole lot smarter, gives it the ability to do very specific, focused kinds of work, and things that in another 5 years won't really be talking about AI per se in terms of those technologies. There may be a large language model that's actually behind it, but it's like a
yeah,
lot of new technology transitions. It's being able to get to that the integration in which that starts to really go away from the common conversation. Yeah, a lot of that's there. Now, if you think about the extent to which enterprise is going to be actually leveraging all those capabilities, hey, outspending the hyperscalers starts to make a lot of sense in that scenario
yeah,
as the
mm,
end consumers. Uh, the question to my mind is what's the degree to which enterprises are going to actually have to think about that? Uh, and today, you got to, we're in that DIY phase. You got to build it yourself. You got to figure
right,
out what the models are. You probably got some guidance and a narrowing of that field in terms of where that all fits. Uh, but even as we start looking, in the 3 to 5 year range, this is a transition that more of this starts to get integrated in ways that enterprises don't have to be as aware. Yep, they're still going to be consuming it. Yep, they're still going to be
mm,
running significant models in some form or fashion. Uh, but we then start to shift in things that are a little more targeted to specific functions and purposes. mean, right now you get people chucking, billion parameter models at
Mm,
problems that could, easily be tackled with an optimized model that's much smaller. But that takes time,
yeah.
and that was sort of the deep seek moment, I think, that started to at least raise some awareness of, when you have the time to be able to optimize, um, there's a lot more that you can do a lot less.
Mm,
Uh, Now, granted, right now, given where costs are, there's not a lot of motivation to do that. You should go out and throw the model that you think is going to work. Um, Go big. Why not? Because there aren't any necessary cost penalties around it. Um, but yeah, when we think about what that means in terms of growth, it says that curve starts to flatten at some point, just in terms of the amount of computational horsepower that gets used, and the way in which we actually start to come at some of these problems. Because
yeah.
that's, I think, the thing that we can definitely be assured of is the way we're consuming AI today is going to be a very different thing than the way we're going to consume it a few years out.
I think that's for sure. And I think to my mind as well is that are we also yeah, I guess it's not like if I think we are, and that's we're going to have to really rethink enterprise compute infrastructure. So it's almost like when we transitioned, like from in essence another three-letter word for you, SNA, right, and mainframe computing into the internet. That was a massive change in architecture and in infrastructure. It took a long time, but it was like so many companies innovating, so many companies like participating in that. I'm not sure if it's going to be that way, but there's clearly got to be a different kind of architecture, especially if we're, if our world is going to like really be so many agents distributed across an infrastructure that you own and that you don't own, right? And then so there's a whole other layer of security. There's a whole other layer of kind of data management, a whole other layer of networking that's required in there. And I think there's going to be just a lot of opportunity for on the vendor side to basically produce new products to address that. And I think on the consumer side, I think that's a lot of what they're seeing this come down the road, and I think they're just all now at the height of attention, to kind of understand what this is and how big of a disruption that's going to be and how to get ahead of it. So
Oh yeah, you're absolutely right. I mean,
uh,
look at the boom in MCP. I
yeah,
mean, you got, a spec that got released in November last year, and suddenly everybody's got an MCP server.
yeah,
What could go wrong?
yeah, yeah. MCP, A to A,
A. Yep. Hmm.
even Cisco has their Cisco Agent Directory. There's like NVIDIA. Let's see, it was Kevin Deering at the last summit was talking about an AI router. So it's like, yeah, there's like a whole new series of products that come out. Even if you think about Hypershield, that Cisco, launched, very different approach, and even firewalls, like, the firewalls, like that market has got to implode. Like how you have firewalls in between agents is beyond me. I think you were mentioning, kind of SASE and zero trust and identity. That's got to be the way that this infrastructure moves, and especially a new definition around identity here. So anyway, I think I don't want to end that way. It seems like a bad way to end, but we're running out of time, So I want to give
Well,
you the
it's a
last word,
future-looking
Eric.
end.
Yeah,
It's a lot of that. I think, Nick, as you were pointing out, this is an area where it's we're raising the levels of abstraction.
mm,
We're able to accomplish a whole bunch of new things. And your points about telemetry, I think, come back to what is that really the really critically important part of this, which is that, you know, being able to think in new ways uh, can open a whole bunch of doors for us.
mm,
And
yeah,
that's something that, again, if we can take this in small steps, like you were pointing out with, focused agent use, uh, this is stuff that there's tremendous potential, but it's yeah, maybe, it's happening a good deal faster than some of our previous tech transitions.
Hmm.
but there's a lot of interesting potential, and I think a lot of good places to go with it. So
Yeah.
we just need to keep
Hmm.
one eye on the wheel as we keep going.
Well, for sure. I got to tell you one quick thing though. For in New York, we have Daniel Conroy. He's a CTO over at Raytheon. He's going to be doing a keynote with DXC. What they're going to talk about is really pretty fascinating. I never thought about this, but they want to apply AI to like tech debt. So it's how do you, we used to use the word like refactor, right? But it's more like how do you suck out the customer data that's locked into these legacy systems, rewrite them utilizing, agents and AI into like a new applications that expand the experience for the end user and also increase the revenue for the enterprise and get out from under tech debt. It's like, and they've been doing it over at Raytheon, so they're going to actually show this and demonstrate this. It's like this tech debt problem has been around for like decades, and everyone tries to solve it kind of like in the same old way. And the problem is that it's so expensive because it's almost like my wife has a really, she really kind of like let this sink into me. We had a pool and I wanted to put a new pool in. And she was like, we already have a pool. Why do you want to put a new one in? You know, and it's just when you have something that works and you want to replace it, it's really expensive, right? Because that ROI basically isn't there. Moral of the story is I put the new pool in. She loves it. She's like, oh my God, this is like so great.
Why did we wait?
Yeah.
Well,
Anyway,
it's there are a lot of aspects I think of AI. We're going to get to that sort of like why did we wait kind of.
I think so. I think so. Hey, Eric, this has been like so much fun. We covered so much ground, in this chat. So I just want to thank you again for taking the time, for being on the pod. Please do send us the link to the Smart Cities, Next in Tech podcast, so we can include it.
I
Okay.
will do very definitely. Well, it's been great. Thank you, Nick.
Awesome. Great. Thanks, Eric. Thank you, everyone.